everybody, welcome to Unit 5, Video 7. I can add, subtract, multiply, and divide complex numbers. All right, so the complex number is a number in the form of a plus bi, where a and b are real numbers, and I is the imaginary component. So you have a is the real part, and bi is going to give you your imaginary component, right? So let's go ahead and simplify this. We're going to distribute the plus sign to both of these. So then this becomes 9 plus 2i plus 1 minus 7i. So then we're going to combine our like terms. So the real part right here, 9 plus 1 is going to give us 10. And then we're going to combine 2i minus 7i, and that's going to give me negative 5i. So now it's in the form of my complex number. So there's my answer. All right, so let's go ahead and go to number 2. So same thing, you start by distributing the plus sign. So we have 3 plus 6i plus 4 minus 2i. So then again, we're going to go ahead and combine our reals. So 3 plus 4 is going to give us 7, and 6i minus 2i gives me plus 4i. Oops. And so then here's your complex number. All right, let's go ahead and go to number 3. So I want you to go ahead and pause the video and try to do this one. Okay, so hopefully we all got 3 plus 2i. And so then remember with this last one here, we want to go ahead and distribute that negative. So we have 3 minus 2i minus 2 plus 3i. So then if we combined 3 and negative 2, so we have 3 and negative 2, that's going to give us 1. And then negative 2i plus 3i gives us plus 1i. So 1 plus I. All right, so that was addition and subtraction. So now we're going to do multiplying and dividing. So let's go ahead and use our distributive property here. So we're going to multiply. So 2 times 3 is going to give us 6. 2 times negative 2 is going to give us negative 4i, or sorry, negative 2i. And then right here we're going to multiply 5i times 3. So that's going to give us plus 15i. And then right here we're going to get negative 10i squared. So then when I simplify, I have 6, negative 4i plus 15i is going to give me plus 11i. And then right here is where we need to simplify into a real number, because we know I squared is negative 1. So we want to think of this as negative 10 times negative 1. So then I get 6 plus 11i plus 10, which means now the 6 and the 10 can be added together to give me 16 plus 11i. So then this is my final answer. All right, so for number 6, we need to distribute 3i to both of these. So we get 6i minus 9i squared. So I'm going to bring this 6i, and now remember I have to simplify. This is negative 9 times negative 1, because remember I squared is equal to negative 1. So again, I'm going to multiply negative 9 times negative 1, which gives me plus 9. But this isn't my final answer because it's not in the form of complex number. Remember, the real component goes first, so 9 plus 6i. It always wants to be in the form a plus bi. All right, let's go ahead and go to the next page. So on the next page here, again, we're doing our distribution. So when you distribute these ones, remember you're doing to both terms. So we get 36. Here we're getting negative 6i. Then on the inside term, we get a positive 6i, and then we have negative I squared. So when I combine my like terms, negative 6i and positive 6i are going to cancel. And then remember, you have negative, there's really an implied 1 here. So you're saying negative 1 times negative 1, because I squared is negative 1. So it's a negative times negative 1, or negative 1 times negative 1, which is going to turn into a positive 1. So we get 36 plus 1, which gives us 37. All right, so for number 8, remember when you have quantity squared, you want to write it out twice. Don't just distribute the square. You want to think of it as 3 plus 2i times 3 plus 2i. Okay, so I want you to pause the video and go ahead and try this one. Okay, so we got 5 plus 12i. All right, let's go ahead and go to the next one. Again, remember you want to write it out twice. So we have rad 3 minus 2i times rad 3 minus 2i. So again, go ahead and pause the video and try this problem. Okay, so hopefully we got -1 minus 4i rad 3. Okay, so let's take a look at number 10. So number 10, remember, I is the square root of -1, and you can't have a radical in the denominator. But remember, 2 plus I is an expression, so they're bounded by this invisible set of parentheses. So you can't just multiply I to the top and to the bottom. What you have to do is multiply by the conjugate so that it becomes a whole number. So then we're going to multiply by 2 minus I, 2 minus I, because remember, that's the conjugate, the same expression but with the opposite sign. So when I distribute the numerator, I'm going to get -10 plus 5i. And remember, when you're multiplying by the conjugate, we know the middle term is going to cancel out. So I just need to multiply the first terms together. So 2 times 2 is going to give me 4. And then the last terms together. So I times -I is -I squared. All right, so before I do anything with the numerator, I'm just going to rewrite it. I want to go ahead and simplify that denominator. And so remember, 4 minus I squared is -1. So this becomes 4 minus -1, which is going to give us, so I'm just going to rewrite the numerator again. And 4 minus -1 turns into 5, because remember, it turns into 4 plus 1. So now I want to simplify if possible. So remember, there's an implied parentheses. So I'm going to factor in a GCF here of 5. So then I'm left with -2 plus I over 5. And now these 5s can cancel out. So my final answer here is -2 plus I. All right, let's go ahead and go to the next one. So again, I need to multiply by the conjugate. So I have 3 minus 4i, so I'm going to multiply by 3 plus 4i to the top and to the bottom, 3 plus 4i. Okay, I want you to pause the video and I want you to try this problem. Okay, so our final answer here is -4 plus 3i over 5. When you simplified it, you might have gotten 3i minus 4 over 5, but remember, we want it in terms of a complex number, so we need the real component first, then the 3i, the imaginary component, second. All right, so again, with number 12, we need to go ahead and multiply by the conjugate. So you want to multiply the numerator and the denominator by 6 minus 2i. So 6 minus 2i. All right, so go ahead and pause the video and try this one. Okay, so let's go ahead and take a look here. So our final is 7 plus I over 20. So make sure here when you're distributing, because on the numerator, they're not conjugates, you're multiplying 2 binomials, you are going to get this middle term here of plus 2i. And then make sure -2 times I squared is a +2. So that's where I'm getting this 14. Okay, let's go ahead and go to the next set of problems. So number 13 here. It says, find the reciprocal of the complex number. All right, so we have 2 plus 3i. So remember, there's an implied 1 underneath here. So if I take the reciprocal, I would get 1 over 2 plus 3i. But now I have I in the denominator, and I can't have I in the denominator because remember, it's a radical. So what I need to do is, like I was doing with the above problems, I need to multiply by the conjugate, so 2 minus 3i. So I'm going to multiply that to the numerator and the denominator. Here I'm going to distribute. The numerator is just 1, so it's going to stay the same, 2 minus 3i. And on the bottom, I'm going to get 4 minus 9i squared. So then I'm going to take a shortcut here. Remember, I know I squared is -1, and I know that -9 times -1 would give me a +9. So 4 plus 9 is going to give me 13, okay? So I said I squared is -1. I multiplied it by -9, which got me the +9. Nothing can reduce, so this is my final answer. All right, so let's go ahead and take a look at 14. So again, with 14, we need to find the reciprocal. So we know that there's a 1 underneath. So if we flip it, we're going to get 1 over -rad 3 plus I rad 6. And again, we have these radicals in the denominator, which we can't have. But remember, they're an expression, so they're bounded by parentheses. So we're going to multiply by the conjugate, which is going to be -rad 3 minus I rad 6. So we have -rad 3 minus I rad 6. And so then in the numerator, we're going to go and distribute. All right, so we get negative rad 3 minus I rad 6. And in the denominator, we know that negative times a negative is a positive, and rad 3 times rad 3 is just going to end up with a positive 3. So then when I do, let's change pens. So then when I do this last term here, I get I times negative I, rad 6 times rad 6. So this is going to give me negative 6I squared, which remember, I'm going to simplify this. So let me just rewrite the numerator. So I get negative rad 3 minus I rad 6. And then in my denominator, I have 3. Negative 6 times I squared is negative 1. So negative 6 times negative 1 is a positive 6. So then when I add 6 and 3 together in the denominator, I'm going to get 9. And in the numerator, I still have negative rad 3 minus I rad 6. Now there's no GCF or like term or anything, so there's nothing to simplify. So then this is my final answer. Okay, so let's go ahead and go to our last problem. Oops. And so for this one, we are finding, or if f of x equals x plus 1 over x, we want to find f of 1 plus 3i. So let's go ahead and we need to rewrite f of 1 plus 3i. So that's what we're finding. So equals, so wherever we see an x, we're going to plug in 1 plus 3i. So we have 1 plus 3i plus 1 over 1 plus 3i. Okay, so remember, the first thing we need to do before we can add these together is we have to get this I out of the denominator, because we're not allowed to have radicals in the denominator or an I in the denominator. So I'm going to multiply by the conjugate, which is 1 minus 3i. So I'm going to do that to the top and to the bottom. Okay, so I want you to pause the video and do that, and then we'll see what you get. Okay, so hopefully we all got to this point. When we distribute here, we got 1 minus 9i squared. Remember, I squared is negative 1, so negative 9 times negative 1 gave you plus 9. So 1 plus 9 gave us 10 in the denominator. So now we need to add these, but remember, over 1 plus 3i, there's that implied 1. And in order to add fractions, they have to have the common denominator. So between 1 and 10, the common denominator is 10. So I'd have to multiply the numerator and the denominator by 10. So on the top one, I need to distribute here. So that's going to give me 10 plus 30i over 10 plus 1 minus 3i over 10. And remember, I didn't have to do anything with this second one because it already had the common denominator. So now I can just add the numerator across and combine the like terms. So 10 plus 1 gives me 11, and then 30i minus 3i gives me a plus 27i over 10. So let me rewrite this, over 10. Okay, so now the way we write our final answer, so we say f of 1 plus 3i is equal to 11 plus 27i over 10. Okay, so thank you for watching the video.